Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we're going to learn how to apply combined transformations using the replacement method. It is a powerful and visual way to understand how transformations affect graphs. Whether you're working with equations, graphs, or even non-functions, this method will help you predict exactly what's going to happen without needing to memorize long formulas. So let's get started. Now, what is the replacement method? The replacement method is all about changing the variable in the original equation. So if we have a transformation that affects x, you're going to replace x in the original equation. And if there's a transformation that affects y, you're going to replace the y in the original equation. So we use this method to build new equations as we transform the function one step at a time. So what exactly does that mean? Let's take a look at this in practice using an example. So now suppose we start with a basic function, y is equal to some function of x, and we want to apply the following transformations to it. We want to translate 2 units to the right, and then reflect over the x-axis. What is going to be the resulting equation? So note that under the original formulaic method that we covered, we were often working in a prescribed order. So we had to do our stretches and reflections before our translations. But in this question, we're being asked to apply the translations first and then the reflection, which is why we're going to use the replacement method here. So the first thing we're going to do is take a look at the first transformation. So that says translate 2 units to the right. So going to the right affects our x, which means we're going to replace our x with x minus 2. Now the next step is to reflect over the x-axis. And reflecting over the x-axis is a change in y. So that means we're going to replace the y with negative y. Okay, so now what that means is the first step is going to be y is equal to, replacing the x with x minus 2 is going to become f of x minus 2. And then the second step is to replace the y with negative y, which means it's going to become negative y is equal to f of x minus 2. So now, let's say we go ahead and isolate y. Then we end up with y is equal to negative f of x minus 2. So that is going to be our equation. So now if you look at this, you can say that this is actually what we would have expected from the formulaic method. And you might be thinking, why would we need to learn this new replacement method if we could have gotten the exact same answer using the formula? Well, it's only because this particular question was constructed in a way where the order of transformations didn't matter. Meaning, translating 2 units to the right and then reflecting, or reflecting and then translating, will actually net us the same result. So let's take a look at the next example where the order of the transformation actually does matter. So for this problem, we have our function y is equal to square root of x. And we want to apply the following transformations to this function, but in 2 different orders. So meaning, part 1, we're going to reflect over the y-axis and then translate 4 units to the right. And then we're going to apply the same 2 transformations, but we're going to flip the order. So meaning we're going to translate 4 units to the right first, and then reflect over the y-axis. Reflection, that means reflecting over the y-axis means we're going to replace our x with negative x. So what that means is we get y is equal to the square root of negative x. And then we're going to do our translation. So we're translating 4 units to the right. Okay, so again, that affects our x, which means we replace our x with x minus 4. So this means our equation becomes y is equal to the square root of negative, and then in brackets, we're going to have x minus 4. So now, let's say we want to do it in the opposite direction. So meaning we are going to do our translation first. So same thing, translating 4 units to the right means we're going to replace our x with x minus 4. So that means our equation becomes y is equal to the square root of x minus 4. And then we're going to do our reflection, which means our x is going to get replaced by negative x. So that means our equation is now y is equal to the square root of negative x minus 4. So notice how the final equation in these two parts are actually different. So, and this is because we performed our transformations in opposite order. So the replacement method is a versatile and reliable way to perform combined transformations, allowing us to apply them easily regardless of the order they come in. So now let's take a look at a more complicated example. So suppose that you are given the graph of the quadratic equation y is equal to negative x squared plus 4x minus 1. And we would like to apply the following transformations to it without drawing out the graph. So we want to reflect it over the y-axis, then translate it 5 units up, and then finally stretch it horizontally by 2. So transformations by replacement is perfect for a question like this, because this equation isn't presented to us in that formulaic format, as there is more than one x in the equation. By replacement, we can perform this transformation step by step. So let's get started. So for reflecting it over the y-axis, that is going to be replacing x with negative x. Translating the graph 5 units up is going to be replacing the y with y minus 5. And then stretching it horizontally by a factor of 2 means we're replacing the x with 1/2 x. Okay, so these are the 3 transformations that we're going to perform, and then we're going to do it in this particular order. So this means we start with y is equal to, we're going to replace our x with negative x, so that means this will be negative and then negative x squared plus 4 times negative x minus 1. Okay, so let's go ahead and just simplify that. That's going to be negative x squared minus 4x minus 1. So this is our first transformation. So we'll put a little 1 beside it. And then now our second transformation says to replace the y with y minus 5. So that means we're going to get y minus 5 is equal to negative x squared minus 4x minus 1. Okay, and then again, we're going to move the 5 over, so that'll be negative x squared minus 4x plus 4. And then finally, we're going to perform our third transformation, which is stretching it horizontally by 2. So that tells us to replace x with 1/2 x. So meaning we're going to get y is equal to negative 1/2 x squared minus 4 times 1/2 x plus 4. And then finally, we're now going to simplify this, and that is going to end up with negative 1 over 4 x squared minus 2x plus 4. So this is going to be our final equation. And notice how this final equation is found without needing to change it to the vertex form or graphing it out. So now let's do a quick recap of everything that we have learned in this video. So what we're going to do is we're going to use x replacements to handle all of the horizontal transformations. And then we're going to use y replacements to handle all of the vertical transformations. And notice that the order does matter. So the order that you perform all the replacement is going to follow the order of the transformation. And you can apply this method to any equation, even if it's not a function. So this is a super helpful technique, especially if you're dealing with equations more than graphs. So now for check your understanding, we are given the equation of a circle. So notice how this is not a function. Okay, so we have the equation of a circle, which is x squared plus y squared is equal to 9. And we want to apply the following transformations. We want to first stretch it vertically by 2, and then shift it down 3 units, and then we shift it 4 units to the right. So what is the resulting equation going to be? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on combined transformation in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.